Solid Edge ST3 provides synchronous assembly design and provides a full range of applications. Solid Edge ST3 includes synchronous assembly design with part-to-part associativity, allowing you to change relationships for modifying part position or geometry in a top-down or bottom-up approach. There's no need to have multiple CAD systems used by your supply chain. Solid Edge is able to import data from most popular systems through direct translators and others by using neutral file formats such as IGES and STEP. Here we're adding a part from Inventor. This is a motor to drive our mechanism, and we're just going to use assembly relationships to position it. The next part that we want to add is coming from SolidWorks. This is an adapter plate that's going to go between the Inventor part and the mounting sheet metal bracket. Once again, we'll just use assembly relationships to position the part in our subassembly. We'll create an alignment between the center hole in the SolidWorks part and the center hole in our bracket. We'll mate the back face of the SolidWorks part to our sheet metal bracket. And then we'll just align one of the corner holes. This will fully constrain this part in our assembly. Next, what we want to do is create an inner part copy of the flange detail of the Inventor part. You can see that the flange in the SolidWorks part doesn't match up with our motor. So we can reuse data in a single system and establish relationships no matter where the data came from. So here we're just going to create this inner part copy of this set of faces from the Inventor part. The next thing I want to do is break the associativity between the Inventor part and the SolidWorks part. So just take this inner part copy and break that relationship. Then what I'll do is just reposition that set of faces back onto the flange of our SolidWorks part and attach it to the model. And it will become part of the solid. Final step here is just to change the color so that everything matches. And then what I'm going to do is use the background data. You can see the Inventor part there. And I'm just going to take the front face and the back face of this flange and use the Synchronous technology and actually move this out to match up with our bracket, or with our motor rather. It's also possible to make use of imported parts and establish part-to-part relationships at any time to accommodate different design goals. So here we're saving some relationships within our SolidWorks part, and then what we want to do is actually create some inner part relations between the SolidWorks part and the Inventor part. So here we can get a nice dialog that tells us what relationships it found. It found some coplanar relationships between some faces, as well as some concentric holes. And you can see that it copies that geometry into the SolidWorks part. We're going to do the same thing with the bracket, the sheet metal bracket. This time we only want to find the concentric holes. By saving these relationships within our SolidWorks part, we can switch back to the assembly. And from the assembly we can use Synchronous technology to move faces in the parts. So I'm using the Synchronous technology to move this face of the sheet metal bracket. You can see that the hole is coming along because of live rules. And once we commit to that change, you can see the SolidWorks part, because of those inner part relationships, will update to the change. We're going to do the same thing to the Inventor part. I'm going to select a face on the Inventor part and make it larger. Remember that we established those inner part relationships, the concentric holes and the coplanar faces, so that again, once we commit to that change, the SolidWorks part is going to update because of those inner part relationships. The same can be done with sheet metal files. Let's switch our configuration. And here we're looking at the floor panel in our lawn mowing machine and some brackets. And what I want to do first of all is establish a relationship between the face of the floor panel and the face of the bracket to make sure that those are aligned. So I'm just using the relate command to actually move that into position. I'm going to use Synchronous technology again to grab the thickness face of the sheet metal and drag it down to the center of the bracket. So this way we can ensure that this fits together correctly. We can also create some assembly features in ST3. So here I'm going to create some assembly driven part features. So these features would not actually be added until the machine was actually assembled to make sure that all the holes lined up. Because it's being welded together, it's not precise. So we create these assembly features at the assembly level. Here I'm just offsetting some construction geometry. And then what I want to do is add some holes. We'll establish this as a 12 millimeter diameter hole and that we want it to go through all parts. I'll just use the construction geometry to place these holes, and I'll add some dimensions to actually constrain them. We're going to use our smart dimension, and we want that distance between to be 45 millimeters, and then on the left side we want this dimension to be 35 millimeters. We also want to establish which parts are being cut by these holes. So you can see that it's actually going through some parts on the outer edge here, and I want to just remove a few parts here and then allow that hole to cut through both brackets and the sheet metal part. There you can see the hole cuts all the way through. Next, we're going to create inter-part relationships again between the bracket and the sheet metal part. Notice that it finds the coplanar relationship between the sheet metal part and the bracket, and we're going to save that relationship in the bracket. So now if I change the sheet metal part by adjusting this angle, I'm going to make this 8 degrees. I'm going to increase this by 8 degrees, this angle. And what you're going to notice is that the brackets on the sides are going to update because of that saved relationship within the bracket. Also notice that the assembly features will update to the correct position. We'll show that one more time by moving this floor panel. I'm going to move this face out 35 millimeters. And notice how the bracket is going to track with it, as well as the assembly features, the holes. Solid Edge ST3 is complete assembly design with all assembly applications, including tubing, piping, weldments, frames, and more. So here what we're going to do is take a look at wiring and how it behaves in ST3 as an example. So we're just going to transition into the wire harness design, and we're going to create some wires between some existing components in our assembly. Simply select the input and the output of the wire from one component to the next. And then I need to define the type of wire that we're going to be adding, and in this case it's 14 gauge aluminum. We also establish the color. And we'll just continue to do that and add a few more wires. Again, we'll establish a different color for this particular wire. And then we'll add one more. To the bottom of this component. And again, change the color. We'll make this one orange. Now that we have the wires established, what we want to do is bundle them together into a cable. So using the cable command, I'll select the 3 wires I just created, and then I'll define where I want the cable to reside. So I want it to go through these 2 brackets, through the sheet metal part, and then I want it to be tied with a wire tie represented by this sketch. Finally, I just define the type of cable. It's a 3-strand 14 gauge cable. And then I can also represent this with actually a solid. So what I'm going to do is just select the harness, and I want to create the physical conductors. You can see that it creates the solid model represented by those wires. So now what we want to see is how this reacts if we make some synchronous changes to our assembly. The first thing I want to do is I want to move the two holes that are coming through the sheet metal part. We're going to move these cylinders out, and you can see that as I begin to drag this, Synchronous technology keeps the two holes aligned along the z-axis. I'm just going to move these out 50 millimeters. Notice that the grommets as well as the wires track with this change. We'll make one more change. We're going to take this bottom cylinder, this bottom hole in the sheet metal part, we're going to move it down. And once again, you're going to see the grommet goes with it, and the wire also gets updated to the new position. And then the final synchronous change I'm going to make is to move the bracket that the wires are going through. I'm going to move it up 30 millimeters, maybe to create some clearance. So with an integrated design environment, Solid Edge ST3 fulfills the vision of Synchronous technology for accelerated design, faster, more flexible change, and more reuse with imported data.